So this is going to be a slightly different video in that I've already written the code that I wanted to kind of write for this, and I'm now going to kind of talk back over it. And part of the reason for doing that is because I tried to kind of create the video as I was kind of writing the code, and I got myself into a bit of a pickle with the Mongo database. And so I thought I'd kind of just kind of get that sorted, and then kind of go back over it again and sort of show what I've done and the issues that I kind of came up with. So before I kind of dig into that, I just wanted to kind of highlight where we got to with the architecture so far. So in the previous video, I implemented the user DB class and the user session DB class to kind of complement the user API class, and I extracted out a DB interface and a database class, which looked a little bit like this, with an add and a find method on it. And so that kind of gives us something where we've now got this, hopefully a relatively thin generic database class that can be swapped out with something else. So that works well as an in-memory thing, but now I want to sort of show that you can replace it with a real kind of database like, say, Mongo. And also then at some point, not in this video but in a future one, I want to show that where we've got our tests running the user API, that you can plug in Express. So we will end up with something along the lines of maybe this. So I'll kind of create a Mongo class to kind of work to the same interface, and I'll see if I can create what I would consider to be a contract test to show that the way this class behaves and this class behaves are the same. And then we'll also, say in a future video, shove an Express kind of front end on that, just to show that it can actually be made to work properly. So it's basically it's the Mongo DB contract test piece that I'm going to work on now. So it's not really so much kind of TDD there, because the DB class and the interface and everything already exist, and the test doesn't exist. So I'm going to write that, and I'm also then going to write the Mongo class as well. So having the change that I had to make here, and I'll kind of come on to kind of why this is a little bit later, was I'd previously got like just a predicate function there, which just said it took a record and then performed some thing to say, it took a record and it returned a boolean, and then it would do something in there with that. So it would just basically run the kind of predicate method there, and you'll see now, rather than having that kind of method, I've now explicitly got a key and a value where it's going to then kind of perform that check with the record key against the value. So I'll come on to kind of why that had to happen. But before I do that, let's go and have a quick look at the test. So this is my test, and originally you can basically pretty much ignore kind of all of that. You can ignore that, and you can ignore that last bit there. So this was the test. This was more or less the test that I wrote, but rather than having this DB factory name and DB factory create in there, it was literally just creating an instance of the database. So, and I was testing then that you can add a record and find it again. So add a record and then find the record and assert that you're actually getting the record back, and then also asserting that if a record doesn't exist, that it throws an error. And I was doing that in a little bit of a hacky way by shoving it in a try catch statement and saying, right, await that, and if it doesn't throw an error when the record doesn't exist, then we're going to fail it, and if it does come back, then we're just going to assert that the error message we get back is what we expected. And what I then added was, effectively, because I wanted to be able to run this against two different implementations and create that kind of like sort of notion of a kind of contract test to show this one kind of works and this one works, I've just kind of created this this array of databases basically to run, so we can run the same tests against the existing in-memory one, and then run the same tests against the Mongo one. There are probably a multitude of kind of better ways of kind of setting this up, but I thought it kind of neatly kind of illustrated how I wanted it to work. So if I just save that at the moment, we can possibly, let me just cancel out of that there, clear that, and run the tests again. and we probably wouldn't want to run all these in normal circumstances. We wouldn't want to run all these tests all the time. We'd want to treat the user API spec as a kind of unit test, and this is a contract test. So the contract test would only really run as probably part of CI and that kind of stuff. The user API spec, because that is a proper unit test. We could obviously run those as often as we like. But for the purposes of this, I'm running them all at the same time. And so we can see there we're running the in-memory DB, although I can't spell it, in-memory DB there, and it's checking that the record exists and the record doesn't exist, and it's throwing errors and all that kind of stuff, and the user registration, everything all works as it's supposed to. So then I added a Mongo database in there as well. And a few things I'll just mention about this. One is that, so it's not really sort of showing up here. I wonder if it'll show if I do Mongo test. So this is actually an issue which I haven't resolved yet, but I should kind of fix it. So because we're opening a connection to Mongo here, I'm not actually closing the connection again. So you can see when I run the test, that's not in watch mode. That's just it's just got to the end and it hasn't kind of returned. So I need to do something in here to actually have a kind of like a teardown thing that will actually sort of stop the thing from running at the end. But I can do that relatively easy. That may be something I'll tag on to the end of the video. But that was the need to disconnect. That was the reason why I've actually kind of creating the Mongo client. So this is the actual third-party library. That's the thing. That's just I've actually installed that as a module, and then I've written my own kind of class as a wrapper to that. So here I'm running the kind of connect, and what I'll do is I'll create another kind of like a destroy kind of function here or something. That will just go in there and disconnect it. So I will kind of come back and sort that out. So let's have a look at that Mongo DB class. So I found out. So this is Mongo DB. Let me just open that to the side. Let's get rid of that. Let's look at the DB. So here are the two. Here are the two classes. So obviously that's got the interface defined in it, but you can kind of ignore that for the moment. We've got the in-memory DB here, and we've got the Mongo DB just here. They've both got a constructor, of which this one doesn't take any parameters, but the Mongo one takes a Mongo client. They've both got an add method, and they've both got a find method. The in-memory DB has got a little ensure collection thing that just makes sure that if we're trying to add stuff or find stuff in a collection that doesn't exist, it goes and initializes it so that when we perform our array methods on it, that there's actually something there to perform it on. In the Mongo DB, we've got a little getDB collection method that just makes sure that when we run this operation, we're actually operating on the appropriate collection. So there are a couple of issues here. So one, when you create a record in Mongo, it creates an underscore ID property attribute, which is of type object ID, exhibit A, object ID. And I didn't actually want, and that's not part of my class. It's not part of my user class or my user session class. So what I've done here, just to kind of again hack my way around that a little bit, is I'm going and inserting the record here, and you'll notice that I'm using a kind of little clone method here, which is just basically stringifying the object and then passing it back again. And the reason I'm doing that is because the Mongo method modifies that record object and adds the underscore ID property into it, which I didn't want. I didn't want to kind of be modifying my original record. In part, it makes it difficult for me to then remove the underscore ID from the object, because if I try and just do delete record._ID, I get a TypeScript error saying, well, hang on a minute, underscore ID doesn't exist on your type. So by doing that, I preserve the integrity of the original record object, and I can then just generate, or basically kind of create, pull out the ID from the insert record and return that as part of my record. So I'm effectively doing the same thing as this, where this creates the record with an ID. This will also then basically return that record with the ID. So in Mongo, it's got an underscore ID field. I'm presuming at some point it may end up with an ID field as well. But when I do the insert here, I'm actually making sure I'm kind of that's slightly abstracted away, and the object I return will actually look like the object I want, not a Mongo object. So that's that. That was the add one. The add one was wasn't sort of too difficult. Where things started to fall apart was on the find method. So I say I had a function being passed in here, and that function, when it returned true, was considered to be a match. But on Mongo, that's not how the find method works. The find method works rather than by giving it a method, you give it an object with the keys and values that you want to match. And I couldn't think of an elegant way to get from my kind of predicate method to that type of object. And so I kind of thought, well, for the purposes of this, I'm going to kind of wimp out and just modify my DB interface and just make my life a bit easier. So rather than passing in a predicate method, it's now passing in a key and a value. So when we kind of then try and do a find, it's going to take those values, and it's going to run on our in-memory DB. It's just going to kind of run. It's going to build that predicate method, but it's going to do it using the key and value parameters passed in. It's going to just check that the record has a key with that value, and then it'll find it. And that allows me to do the same thing on Mongo. So again, I can check here that the collection find one has a key with the right value. And the only things I needed to then, the special case that I needed to consider was if we're searching by ID, because the ID in Mongo is underscore ID, and the value of that key is not a string value, it's actually of type object ID with value inside it. So that then worked. So it was frustrating that I had to change the interface, because I was trying to kind of maintain that and then demonstrate that actually look we can create this interface where we want it and then just implement something there. But this showed that I guess that my interface the interface that I created wasn't appropriate for this. So I had to I felt like I had to modify it to make that work appropriately. I guess I could have kind of really kind of hacked it to work, but that would have been a real big hack. So I could have perhaps got all of the records out of Mongo and then kind of run that as a sort of an array find over it. But obviously that would have been it's not really an appropriate way of kind of doing things like that. So in this instance, I thought changing the interface was the appropriate thing. But it shows that it's important to understand the things that you're likely to be using, to have a good understanding of what does an in-memory database look like? Well, what does Mongo look like? What if we were to use MySQL or something here? What can we use them in broadly the same way? Could I have a find method that took a collection, a key, and a value with MySQL and be able to return the same thing? I think I probably could here, because you can probably easily kind of recognize that you could run a SQL command that used the collection as a table and then just said where key equals value. So that should, would expect that would work. but understanding what those things are is key to then being able to define an interface that is well designed and not going to change very often. Because ideally, because this is the seam, this is the boundary of our application. We don't want this to change more than absolutely necessary. We want to be able to change all the code in here and mess around with that, and maybe even mess around with stuff on the outside here. But this interface should not change frequently at all. This is that should be something which is well designed, and when it's well designed, it won't change very often. If it needs to change often, then to my mind that suggests that it's not been well thought out, which was obviously the case for me here. But having kind of done that, hopefully, that kind of shows that having those kind of database tests running, and what I've done, if it's not kind of immediately apparent, I had how do I get my terminal back up again? View terminal. There we go. If it wasn't obvious here, in order to kind of get Mongo running, I had just created a little Docker Compose file that just had Mongo running and exposing the kind of normal port. That enabled me to run my tests against it. Obviously, you could use the Mongo in memory DB module, but for the purpose of what I was doing here, I was trying to kind of keep it minimal as possible on the node modules, and do as much of it as possible with just code and the real Mongo DB. So that means our package.json is still relatively small. We've just got our testing things there. More times, but those that should probably be up in there as well. So really our only two things we're using at runtime are Mongo and UUID for that. Everything else is just used for testing and compilation and that kind of stuff. Hopefully that has been useful. I'd say in the next video I'll probably try and kind of connect it to Express.